Hello guys, hello world, hello Philippines, hello other parts of the world. This is again, I'm a singer, eternal voice, and this is my hot coffee with milk. So before going further, I will say let's support Bongbong Marcos for presidential election race in 2022. My God. So please forgive me, my profile, my Facebook is all about BBN. Okay, so we will show respect each other's right, whom among them we will be able to vote, right? Okay, mass transfer. So mass transfer is all about concentration gradient. Our driving force is the concentration gradient, okay, meaning the difference of concentration from point A to point B, from point B to point C, like that, through any different medium or media, something like that. So this is a transport of a component from a region of a higher concentration to a lower concentration. Okay, oh my gosh, what's happening? Oh. Okay, so let's discuss now. Okay, so we'll base first for the mall and then after mass, right? For the mall, we have here, but before that we must draw. We will have a drawing first. Okay, so this is, oh my gosh, what's happening first? So we'll have a drawing here. Okay, this is say for example, this is our compartment with solution or mixture. Let's say A, like this. This is component A with certain concentration. Again, we have also component B here. And this is component B also with a certain concentration. So let's say this is high concentration and this is lower concentration. So it's gonna be putting symbol. So this is C1. This is here is C2. So C1 is the concentration of this A component and C2 is the concentration of this B component. Okay, and now we have also the distance covered of this A to B because it will move, right? So this is a partition. So this partition is this one. It's a semi-permeable membrane, for example, and this component A will slowly go to the component B, like that. Okay, so from higher concentration C1 to lower concentration C2. So, and then there is also Z. So Z1, Z2, the distance covered here. Okay, Z1, and then so we have also Z1 to Z2. This one will cover Z1, the distance, horizontal, X axis, and then this B also will travel, something like that. But this B will study here. Only what we mean here is the component A, Z2. So this is the initially Z1 of component A and Z2 because this component A will transfer here. So Z2. Okay, something like that. So we have now consider first the mall. So this is gonna be like that. We need to derive a little bit. Okay, so we have the mall area time. So this is our mole transfer specifically. Okay, so we have as let's say flux. So basically this is the definition of flux in terms of mole, because it's also okay to put mass later on, but we will be doing first the mole. It's gonna be the, you know, and this flux is having the symbol of GAZ. So GAZ meaning to say the component A will travel a certain distance Z from going from one region to point 1 to point 2 as shown here. So J as in char, remember that one. And then we have also negative diffusion coefficient DAB. So times D concentration DC, like that. So it's gonna be like this. Okay, this is the equation of the mass flux, but now mole flux in mass transfer is equals to diffusion coefficient component A to B, and then the concentration of C over delta T. So this is a concentration gradient, meaning to say it would involve C and CB later, right? Something like that. Or let us say C1, C2, because represents concentration 1, concentration 2, ganun. So we can say that also as negative DAB, also delta C and delta Z. So the same, the DC is also delta C, and DZ, right, is also delta Z. So delta C is the difference of 2 and 1. Okay, so delta C is equals to C2 minus C1. Actually, okay, delta C is equal to C2 minus C1, final minus initial, but it happens our initial C1 at a higher concentration, right? Because this is mass transfer. So the answer for this is negative. So let's say negative, negative. Okay, because anything minus from a negative is always be negative, because C1 is higher concentration than C2. Okay, now we have delta Z is equal to Z2 minus Z1. It's here, the distance covered here. Okay, Z1 and Z2. So there's no problem, this is positive. Okay, like that. So as we substitute this negative, let's say negative and positive here, let's say diffusion coefficient of DAB is equals to say this delta C is negative, right? Negative, and delta Z is positive. Negative divided by positive is negative. Okay, something like that. And then our diffusion coefficient is negative, so negative times negative will be positive. It's gonna be like this: DAB is equals to C delta Z. Okay, so like that. So this is our equation. Mass flux of component A to B is equals to diffusion coefficient AB times delta C over delta Z. Okay, then we need to account the units na to further understanding so that we can simplify. So since this is mole over TA, T is seconds, A is, let's say, centimeters squared. Okay, so it's gonna be mole centimeter squared times time, this one, this mass flux, oh no, mole flux, this one, mole centimeter squared T seconds, it's in here, mole times second, okay, and centimeter squared the unit of area. Okay, now what is the definition of diffusion coefficient? Okay, so the definition of diffusion coefficient is area over time, or centimeter squared over second. Diffusion coefficient is area over time, so centimeter squared over second. So let's substitute now here also. Centimeter squared second. Okay, so like that. So how about delta C, the unit of delta C? This is concentration, right? So we will express this. Concentration will be equal to the number of moles. Okay, concentration will be equal to the number of moles over the volume. So this is our formula of the concentration, number of moles over the volume. So let's say our number of moles N is in terms of moles, of course, over the volume in terms of centimeter, cubic centimeter, because we are expressing centimeter in this particular derivation. It's gonna be mole cubic centimeter, right? Substitute this mole cubic centimeter here also, and we check, we simplify units. So mole like this, centimeter cube over delta Z, which is centimeter. So this is delta C, mole per cubic centimeter, over centimeter, which is our delta Z. Okay, when we subtract Z2 minus Z1 like that. Okay, so what will happen now? So it's gonna be mole centimeter squared, then like this, cancel, so it's gonna be centimeter second like this, and then like this, centimeter cube like this. Okay, it's gonna be mole centimeter squared second, okay, centimeter cube cm. Okay, this is cm, centimeter cube cm. Okay, so it will become, so this is centimeter cube cm rin siya, ha, because of here. So oh my gosh, wait for a while. It's gonna be like this. So mole second centimeter squared is gonna be like this, centimeter cube, okay, like that, then times centimeter squared over second. So this one cancel, okay, so this one, so this is, okay, this is mole, okay, this one, from this one we arrive to these units. So this is here, right? So we are not accounting yet the diffusion coefficient. So after this times the diffusion coefficient is this. Diffusion coefficient times the diffusion coefficient, this one, times this. Okay, so our answer will be mole like that, okay, and then squared s centimeter squared, okay. So this one will be the answer. Mole per second centimeter squared, in which here mole centimeter squared second, something like that. We're just evaluating the units of each. Okay, so I will make it clear because here this is very too much erasures. Okay, so let's say this one. Okay, so mole centimeter cube over the delta z, which is centimeter. So this is mole centimeter cube. Okay, and then mole centimeter cube times mole centimeter squared. Okay, second, cancel, so this is become mole. Okay, this is gonna be like this, huh? So this is concentration over the z, so meaning moles per cubic centimeter over centimeter z. Then it will become mole over cubic centimeter. Mole over cubic centimeter times the diffusion coefficient, which is centimeter squared over second. The result will be mole centimeter squared second, which is the unit of your mole flux here. Okay, like that. So thank you so much. After this, we'll be able to show to you the mass flux also. That is the mole flux, right? But these are all related to mass transfer derivation of basic equation. Thank you so much for watching for this short live streaming or live video. Thank you so much. Bye bye everybody. God bless. If you think you like this video, you can comment down below in the comment section, and you can click the notification bell for some newest updates. I'm Engr, eternal voice. Bye bye. God bless everybody.